This is a significant moment in the history of organ transplantation. Inside this glass jar in a Boston laboratory is a rat kidney. It's been stripped of its cells, leaving behind this white collagen scaffold that gives the organ its shape. Then the kidney was reseeded with fresh cells and finally transplanted into a living rat. It didn't work very well, but the kidney did filter the animal's blood and produce urine.
The point here is really to show a proof of principle that this technology can be used to regenerate functional kidney tissue. If you're a patient on hemodialysis, kidney function of 10 to 15% would already make you independent from hemodialysis, most likely.
Most people's kidneys are not suitable for transplant when they die, but the hope is this technique could eventually be used to rebuild them with cells from a transplant patient, and that would mean the organ would not be rejected by their body. There are currently more than 7,000 people on the transplant waiting list. Of those, more than 6,000 are waiting for a kidney.
Many people die on waiting lists and not enough people get kidney transplants in a timely way. If we could engineer organs from scratch, use scaffolds, either decellularized or synthetic, and put the patient's own cells into those scaffolds, we could theoretically solve the whole problem of organ donation.
The same technique has been used in animal research to create lungs, here functioning in the laboratory, as well as working hearts and livers. Regenerative transplant medicine has worked with humans. 2 years ago, surgeons successfully created this synthetic windpipe, which had been seeded with the patient's own cells. This latest research with kidneys is highly promising, but several years more laboratory work is likely before patient trials will begin. Fergus Walsh, BBC News.